Now that we're comfortable with some of the vocabulary of a coordinate plane and how to plot a point, we're going to move on and talk about how to perform a transformation. A transformation is changing an image by applying a rule to each coordinate. So a rule might be something like I add 5 to each coordinate to get my new coordinate. Let's talk about just some logistics. If my original point is called point A, the new point wants to indicate that there's a relationship with A, but it's slightly different. We're going to call it A prime. It's written with an apostrophe, but again, it's called A prime. Okay, so let's look at some actual transformations. The first example we're going to talk about is a horizontal translation, okay, or a slide. So if I start with my original location over here, and we're going to list all of the vertices for this figure. So I'm going to list them below. My first one, we'll call this point A, and point A will be at the point 1, 2. We're going to call the one in the lower left corner, this is going to be point B, and point B is 1, 0, and point C is going to be our last point out here, and point C is going to be 3, 0. Now, to perform a transformation, what I'm going to do is I'm going to take my figure and I'm going to slide it horizontally. So that means I'm going to be sliding it to the side. Now, if I slid it to the left, that would represent adding a negative value, but I'm going to slide it to the right, and notice the relationship between where my points were. My original point A was right here. I've slid that point A 3 units to the right. So if we look at our new vertices, we're going to write them down and then we're going to compare. So with my new figure, I'm not going to call this point A anymore. I'm going to call that A prime, and that's going to be the point 4, 2. B prime is found at 4, 0. And C prime is going to be at 6, 0. So now if I compare A and A prime, B and B prime, C and C prime, you notice that what has changed is my x coordinate. It went from 1 to 4, so it increased by 3. Down here in C to C prime, you can see my x coordinate also increased by 3. So another way of writing what that translation was is I could generalize and say that it's x plus 3, comma, y. You might ask why I didn't add anything to y. That's because in this translation, my y's remained exactly the same, 2, 2, 0, 0, okay? But my x's were the ones that changed, and that was because it was a horizontal slide. Let's look at our next figure. All of our original points are exactly the same, so we're going to write those down again. By keeping them the same, I'm going to have the point A at 1, 2, the point B at 1, 0, and the point C at 3, 0. This time, though, I'm going to use a vertical translation. So I'm going to take my original figure and I'm going to slide it up 3 units. 1, 2, 3. So there is its new resting place. So let's look at what those coordinates would give us. This time, A prime would be 1, 5, because I'm going over 1, and up 1, 2, 3, 4, 5, to get the new location of A, or A prime. B prime is going to be at the point 1, 3, and C prime is going to be at the point 3, 3. Hopefully you notice in this example what's staying the same are my x values, so if I'm going to generalize this rule, I'm going to write it as just x. I'm not adding or taking anything away from x. Because my y values are different, I'm going to look at the difference in my y values, and this time it's 3. Only this time it was 3 up, so it's 3 in my y, change in 3 in my y-axis. I'm going to write that as y plus 3. There are two more types of transformations that we're going to talk about on the next slide. For these two examples, what I'm going to do is I'm going to take my original figure, and rather than sliding it, we're going to talk about how to stretch it and how to shrink it. So stretching it would be to make it taller or wider or larger. Shrinking it would obviously involve making our side lengths shorter. Both stretches and shrinks can be made without a reflection or with a reflection. The first example that we're going to look at is going to be a stretch without a reflection. To make things a little bit easier, I decided to use the same points and the same figure so we don't have to go through this again. We have A, B, and C. What we're going to do is we're going to take this triangle and we're going to stretch it out and make it taller but not wider and see what happens to our points. I've just drawn in our new triangle, which is taller than our original, but it has the same width. What we're going to do is look at what our new vertices are. Our A prime, again, that would be right at the top. Our A prime is going to have the point 1, 1, 2, 3, 4, 5, 6, 1, 6. B prime is still in that same spot, 1, 0. And C prime is still in the same spot that it was originally, 3, 0. This looked like a 6. So what happened? Well, all of our x values stayed exactly the same. So when we write this, we would just say x is still the same. But our y values changed. Well, really, actually, just that one y value changed. It became 3 times larger than the original one. Why didn't our second and third get 3 times larger? Well, that's because I would have multiplied by 0, and multiplying by 0 is going to give me just 0. So I would write this as x comma 3y. And the big clue here is A to A prime and figuring out how I'm moving these. Well, why couldn't it be y plus 4? Because isn't 2 plus 4 also 6? If that were to happen, then down here from B to B prime, our y coordinate would have also changed 4, and that didn't happen. That's a big indication that we are looking at a multiplication, not an addition or subtraction. There was no reflection over any axis here. It was just a pure stretch. What we're going to do is we're going to do a stretch with a reflection over here. Because I'm going to reflect it over the axis, I've changed the graph paper to give you a little bit more of a sense of where we are on the coordinate plane. So our last example, you can see that we not only have a stretch, but we also have it reflected over our x-axis. So I think it's going to be helpful to look at our new coordinates again. A prime would be 1, negative 4. B prime, 1, 0. C prime is going to be 3, 0. So again, most of our clues are going to come from A and A prime because B and to B prime and C to C prime remain the same. What happened here is that it got twice as long. So it's pretty clear, because my x-coordinate is staying the same, that my y-coordinate is being multiplied by 2 because it's doubling from 2 to 4. But to change that, or to show the reflection over the x-axis, it also went from a positive 2 to a negative 4. That's my big clue that I'm multiplying by a negative 2 for my y-coordinate. Again, multiplying 0 times negative 2 is going to give me 0 for both my B and C points. So really I'm looking at my A to give me my big clue. The most important thing when you're trying to determine what the rule is, whether it's a stretch, a shrink, a reflection, or without a reflection, or even if we are talking about a translation or a slide, is that your rule is consistent and that you see the same change happening from A to A prime, B to B prime, C to C prime.